Welcome to tutorial 3.2 part 3. This is the last of 3 on the simple patterns of chemical reactivity. This time we're going to have a look at combustion reactions. And what's nice about the combustion reactions is that the products are always the same. It's always going to be carbon dioxide and water that we make, and we're always going to add oxygen to whatever the substance is that we're trying to burn. And the substance will always be a hydrocarbon, so carbons, hydrogens, and there may or may not be some oxygens involved as well. So in terms of making predictions, that's very straightforward. You always write the same things, carbon dioxide, water, and add oxygen. What's hard, though, some of them can be tricky to balance, so they're a good exercise to kind of get used to balancing slightly more difficult chemical reactions. If you look at the exercises here, you have a fair amount of time. You have 4 minutes to do these, which is quite a bit. And you need 10 points. You get 10 points for each correct answer. So you have about 2 minutes to do each one of them. So all around, it's not that hard to get a nice grade. So let's try a couple of these and see how it turns out. So here's the first one. We're going to say C6H12. C6H12. And remember, what we're going to add is always oxygen. And we're going to make two things, carbon dioxide and water. Now notice I'm not putting the phases in because you have no way of predicting what the phase will be of these hydrocarbons. I just left the phases off of these exercises altogether, so you don't have to put any like liquid, gas, aqueous, or solid phase designations. Alright, so let's try to balance this one. I see 6 carbons here on the left, so I have to make 6 carbon dioxides. That's the only place where carbon goes. The 12 hydrogens require me to make 6 water molecules. Then I can just add up the oxygens needed to make this material. 2 times 6 is 12, plus 6 more is 18. So it looks like I need 9 of these oxygen molecules. I think that was pretty straightforward. Let's check it out. Say, yep, that's correct, and it formats it nicely for us. Let's do another one. C4H8O. Again, we add oxygen, and we make carbon dioxide and water. H2O. Let's go for this one. 4 carbons means I have to make 4 carbon dioxides. I have 8 oxygens here, 8 hydrogens here, sorry, so it means I have to make 4 waters. Now let's count up the oxygens. 2 times 4 is 8, plus 4 more is 12. Now I have to slow down. I get 1 oxygen from this molecule here. So of the 12 that I need, 1 will come from here. That means I have to get 11 from this source. 11 is an odd number, and they come in pairs. So what do I have to do? The easiest way to manage this is just go ahead and take the 11, recognizing it's actually twice as many as you want. You wanted 11, but you ended up with 11 times 2 is 22. But if you have twice as much oxygen as needed, then just go ahead and just react twice as much material. So we would double the amount of material we had here, and we would make, therefore, double the amount of material on the other side. And let's check to see if that's right. So I have 2 times 4, 8 carbons on both sides. That looks good. 16 hydrogens. 2 times 8 is the same as 8 times 2. And then the oxygen, 16 plus 8 is 24. I have 22 from this source over here. Plus 2 more is 24. So it looks pretty good. So I think I got that one right. Let's try another one. C9H18. Opa. And again, we add oxygen, always the same. We can make carbon dioxide and water. Let's do this one. 9 carbons means I need to make 9 CO2s, 18 hydrogens, which means I need to make 9 waters. Adding up the oxygens, 18 plus another 9 is 27. So again, it's an odd number. So therefore, I'm going to go ahead and get not 27, but 54, knowing that's twice as many oxygens as I really need, but that's no problem. I'll just double the amount of stuff I'm going to react, and therefore double the amount of material that I'm making on the other side. And I think without double checking, I think it's right. Let's just go ahead with it. How about this one, C9H18O? So C9H18O. And again, we add oxygen, make carbon dioxide and water. Alright, 9 carbons means I make 9 carbon dioxide molecules, 18 hydrogens, which means I'm going to make 9 water molecules. I add them up. 2 times 9 is 18 plus 9 is 27. But this time I need 27, but not from this source. I need only 16 from this source. So I get 1 from this source of the 27, leaving with 26 on this side, so I don't have to do that trick about doubling everything. All right. Oops, well, looks like we ran out of time. I think you get the idea. Practice these. Some of them are a little bit trickier, and you'll see the ones that are the trickiest are when you have an odd number of hydrogens in the molecule itself and some oxygens as well. You'll see how that turns out. What you're going to have to do, well, just go through it back and forth. Those are a little bit harder than the ones I happen to have shown you here, but we'll do those in class if you have any trouble with them. All right, good luck with this. We'll see you in class to practice some more. Bye.